Okay, this chapter, part 3 rather, is going to deal with chapter 3, measurement. We had a lot of different types of measurement. We looked at scientific notation to begin with, something like 3.40 times 10 to the fourth. We looked at the negative exponents. Then we looked at significant figures. We learned what that all meant. We learned about accuracy, precision. There's a lot of things that we learned in this section, so let's go through this. All right, the first one says, briefly explain how you would enter this number on your calculator. Now, this is scientific notation. You are never, ever, ever going to hit times 10. I understand it's in the equation here, 3.40 times 10, but you're never going to type that into your calculator. You're going to hit 3.40, just hit the numbers with the decimal in there. Then you're going to go look for the EE or the EXP button. You're going to hit that. Engineer specifically put that button on your calculator so it indicates the times 10. It means times 10. So you just have to type in the exponent. So you're going to type in the 4. So the 3.40, hit the EE or the EXP button, then your exponent. Never, ever, ever type in the multiplication sign or the number 10. If you do, you're really multiplying 3.40 times 10. So the computer's going to do that first and give you 34.0. Then it's going to change it to the fourth power. So make sure you don't hit times 10. All right, number 23. What's the difference between 3.40 times 10 to the fourth and times 10 to the negative fourth? So I've explained these two answers right here. Let's look at the positive exponent first. Positive exponent means multiply. So you're going to multiply 3.40 times 10 4 times. So it's times 10, times 10, times 10, times 10. And each time you multiply by 10, you move the decimal point to the right, and it gets larger and larger. So we got 3.40 to start with. Multiply it times 10, times 10, times 10, times 10. If the exponent was 82, you would do that 82 times. If the exponent was 4,000, you do that 4,000 times. And you end up with 34,000. Now down here, this is a negative exponent. This means you divide. Negative exponent means you divide. So you're going to divide 3.40 by 10 4 times. So divided by 10, divided by 10, divided by 10, divided by 10. And each time you divide it by 10, you move the decimal point to the left, and you make that number smaller. So we're going to write 3.40, and we're going to divide it by 10. Now we have 0.340. Divided by 10, 0.0340. Divided by 10, 0.00. Divided by 10 the last time. Again, if there was a negative 80 for an exponent, you'd do this 80 times, and it'd be very small. Put a 0 on the front so it looks proper. And then 0.000340. And there's your actual number with the negative exponent. And then finally it says, where would you expect to find this number with a negative exponent on a number line? Anytime you have a negative exponent, it's found between 0 and 1 on the number line. The only way to get it on the negative side is if you have a negative number out front. So if this was negative 3.40 times 10 to the fourth, if you had negative 3.40, it would end up being negative 34,000. So it would be on the negative side of the number line. If it was negative 3.40 times 10 to the negative fourth, then it's going to be between 0 and 1 on the negative side. It's going to be negative 0.000340. So a negative exponent means it's going to be between 0 and 1, either on the positive side or the negative side. The negative out front tells you which side of the number line it's going to be on, which side of the 0. The only way to get on the negative side of the number line is to have a negative out front. The negative exponent will just get you between 0 and 1. Negative exponent means keep dividing. It's going to be a small number. All right, number 24. What's the difference between 3.40 times 10 to the fourth and 3.40 times 10 to the fifth? How many times greater is the second number than the first? Well, 3.40 times 10 to the fourth means that you should multiply it by 10 4 times. And 3.40 times 10 to the fifth means you should multiply by 10 5 times. So basically it's going to be 10 times greater. Okay, every time you multiply, it's not 1 times greater. Even though 4 and 5 are just one number different, that means it's 10 times greater. Okay, number 25 is asking us to convert the following into scientific notation or take them out of scientific notation if they're already in. So this first one we already did. It's going to be 0.000340. Okay, so the decimal point started here originally. We moved it over 1, 2, 3, 4 places and put it back over there because this is times 10 to the negative fourth. So we divide it and make it smaller. 9.00 times 10 to the first means you're going to multiply this times 10 one time, so move the decimal point over here, so it's going to be 90.0. This one is not in scientific notation. We're going to put it in. So the decimal point starts out here, even though it's not shown. You can assume it's there. 1, 2, 3, 4, 5, 6. Remember, you always want one digit to the left of the decimal. So we can just put 7. You don't necessarily have to put any zeros here unless you know how many significant figures it should have. But right now, 7 times 10, and we moved it 6 times. And then check your answer. If you multiply 7 times 10 6 times, you'll get back to this. Over here, we got 3.43 and a lot of zeros on the left of it. We want to put this in scientific notation, so move your decimal point so you have one real digit to the left, not a 0. 1, 2, 3, 4, 5, 6. So it's going to be 3.43 times 10 to the 6th. That is not correct, because if I multiplied 3.43 times 10 6 times, I would not get a very, very small number. I'd get a big number. Positive exponents mean multiply it. I don't want to get a big number, I want to get a small number. So I want to take this coefficient here, this 3.43, and I want to divide it by 10 6 times. And every time I do that, I'm going to get move the decimal to the right here and get smaller. So I'm going to put a -6 there. -6 means divide this number here by 10 that many times, and you'll end up with a small number. Same thing over here. I write 8.8 times 10 to the 2nd. And if I ask myself, is that correct? Well, no, I don't want to multiply 8.8 times 10 2 times. I want to divide to get back to this tiny little number, so I'm going to put a negative exponent. And then finally, 1,240, I'm going to assume the decimal point's here. I'm going to move it 3 places, so I have one digit on the left. 124, you can add the 0 if you need to, depending on how many sig figs you actually need. And that's times 10 to the 3. And then I ask myself, is this correct? Do I multiply 1.24 times 10 3 times and get back to this? Yes. I don't want to divide. I want to multiply. Okay, number 26. Use your calculator to solve the following problems. When you put this stuff in correctly and you don't hit times 10, you hit the EE button instead, you should end up with 4.2 times 10 to the 4th. A lot of times you get a number on your calculator and it won't put it into scientific notation because the number is small enough and the calculator can print out all the digits. You might be asked to turn it into scientific notation. So you have to look at your calculator and put it into scientific notation correctly. Other times the calculator says, I'm not going to write all those digits, I'm just going to put it in scientific notation right off the bat, and it'll spit back out to you scientific notation. This one, by the way, should be 3.90 times 10 to the 4th.